Hello, it's Matthew Dipple with Airtight Engineering, here to talk about Module 6 of our Getting Real About Home Energy workshop for real estate agents here in Saskatchewan. Module 6 is a little bit of a shorter module, and in it we'll be talking about home scale renewable energy. Because it's the most common and is certainly the most allowed in cities for sure, we're going to talk mostly just about solar, is what we'll focus on. So we'll start by looking at photovoltaic solar. So that's what we think of in general. That's the panels that we see in this slide here. So making electricity with the sun. And then second, we'll talk a little bit about solar thermal, so generating heat with the sun. And we'll end off by taking a quick tour of the City of Saskatoon solar map, which is a great tool and resource for you and for your clients. So let's talk about photovoltaic, often shortened to PV solar energy. This is the cheapest source of new energy on a small scale. So on a grid scale, I think wind power currently is coming in a little bit cheaper than solar, but for a home scale, PV solar is certainly the cheapest that we can get. It's becoming more and more common as the price for panels is coming down. Also, as the efficiency of those panels is going up, it's just a great case to use unused roof space or unused ground space as well. So the picture here is of my colleague Stefan's ground-mounted solar array on his farm. In the city, more commonly, we would see roof-mounted arrays. And in some regions, we're actually starting to see solar panels on buildings be mandated. So that's part of a requirement for your building, is that it would generate some energy. So that's not in Canada at this point, but there are some jurisdictions in other countries that are seeing that. Another trend that we're starting to see too is more integration with other building components. So you may have heard of, I think it's Tesla's come out with some solar shingles, or there are some solar siding. So at present, these are fairly costly and their efficiency isn't as good as just the sort of panel version. But that is something that we'll likely see in the future in our buildings, is better integration with the architecture of the building, as opposed to seeing the panel as like a separate piece of equipment strapped onto the building. So let's talk a little bit about photovoltaics and the grid. So there's a couple different ways to do solar power, and the most common is to be grid tied. And so what this means is that you've got solar panels on your roof and you are feeding into the grid that power with a bidirectional meter, so that your power meter can run both ways. And when it's sunny out, you're putting power onto the grid. When it's cloudy out, you're taking power, or when it's nighttime, you're taking power off of the grid. And then SaskPower is, or Saskatoon Light and Power, depending on who you're with, is going to be net metering. So they're measuring over the course of the year how much you put on, how much you take off. So this is the sort of the simplest and the cheapest installation, because we don't have any batteries on site. So we don't have any batteries in our house. We don't need an inverter to switch from the direct current that comes from the solar panels to the alternating current, which we're used to plugging into in a wall socket. So one of the downsides about this type of setup is that if there's a power outage on the grid, our system also doesn't run. And that's because we're feeding into the grid. We aren't just sort of feeding to our house. So we don't have any battery backup necessarily to run our house without the grid there. So in terms of resilience, with a grid tied system like this, without battery backup, when the grid's down, our system's going to be down as well. So we could look at getting a bunch of batteries. That adds cost and complexity for sure, but it does give us some resilience, right? So if the grid goes down, then we do have the ability to island, as it's called, and to actually have our own little power system within our house. A safety feature that needs to happen in both of these cases is, first of all, our solar panels need to have an automatic switch that if the grid goes down, it shuts off the power coming from our panels, because we don't want to inadvertently electrocute a power line worker who's trying to fix things. And if we've got that battery backup system, similarly, we need to have a switch that actually automatically turns from grid power for our house to using that battery backup and cuts the tie to the grid so that our batteries aren't electrocuting someone working on the line. So this is a two different kind of ways of doing solar power, that grid tied only or battery backup tied to the grid. I guess the third would be just battery backup, so actually no attachment to the grid at all. And that would be probably the most expensive just because we need the largest battery system in general. One other interesting thing that's coming down the pipe, or down the street, as it were, is that electric cars, some of them have the ability to actually tie to the grid. And so you might in the future, right now, I think our grid is the limiting factor, but in the future, you might be able to have a setup where if you've got an electric car, you could actually use that car's battery as island power for your home if the grid were to go down. So you could sort of have that car battery play double duty. So that's kind of a cool ability and technology that as we move into the future of smart power grids, we're going to start to see more of. So the other type of solar power is called solar thermal. And so in this type of solar, we are not collecting electricity, we're not generating electricity, we're generating heat. And typically this heat is either used for, mostly it's used for heating domestic hot water, so for taking showers, etc. And sometimes it's also used for space heating as well. We've got two main types of collectors that you might see here in Canada. The first is called an evacuated tube collector. It's showing on the top picture there. So it's a bunch of tubes. They've got a vacuum in them, and they've got some fluid flowing through them, and then like a black or dark colored absorber. And these are really good for cold climates in Canada because they're less sensitive to the outdoor temperature. So when the sun is heating up the fluid in those tubes, because they're under a vacuum, the fluid doesn't then just lose all of its energy to the cold outdoor air. They are, however, more expensive, as you can imagine, and a little bit more fragile as well. The other type is the flat plate collector, which is shown on the bottom photo. And so this is not under a vacuum. It just has a glass panel on the surface, and then it's got the solar absorber or that kind of dark material underneath of it. And it's got a bit of an airspace. So it is more susceptible to losing heat when it's cold out. So if it's minus 30 outside, that's going to be much less efficient than an evacuated tube collector, but it's a lot cheaper and it's a little bit simpler in terms of its construction. So both of these would be used for producing hot water that could be used for domestic hot water or for space heating. We used to see these be a lot more popular than they are now. And part of that is just because the cost of photovoltaic panels has come down so much. And so at this point, the cost for these solar thermal panels is higher per kilowatt hour of energy that we're getting than the cost of PV. And they're also a little bit less versatile, right? We can only generate hot water. We aren't able to generate electricity, which we can do much more with. We also have higher maintenance costs with these because they've got more moving parts. So instead of just electrical wires coming from them, now we've got tubing with water and glycol flowing through it. We've got pumps. We're working with pressure, with fittings, we've got valves, etc. So we've got a little bit more that we need to maintain and is going to wear out and need replacing. The argument for solar thermal is that it's much more efficient at collecting energy than photovoltaic. Maybe I think it's like 2 to 3 times more efficient at collecting the sun's energy. So that's that's the cost benefit analysis, right? So more efficient at collecting energy, but that energy is less versatile and there's higher maintenance costs. So at this point, we're kind of at the inflection where most people are just choosing to go with a few more PV panels rather than adding solar thermal. But there are still cases where solar thermal can make sense for us, for sure. One other cool technology that's up and coming is a combination of the two. So it actually uses solar thermal in conjunction with PV. So it's able to collect both. So you're collecting some photovoltaic electricity, and then you're also generating some heat as well. And the nice thing is for photovoltaic panel, the hotter it gets, the lower its efficiency is. So it's ideal if we have some way to cool that panel down. Well, what better way than flowing some sort of fluid across that panel to draw the heat away from it? And then if we can use that heat, that's just going to improve our efficiency. So that's something that is, I would say, is not huge in a residential setting, but is starting to take off a little bit in some commercial applications. So the last thing that we want to talk about in this module is the Saskatoon solar maps. This is a pretty new tool that the city has come out with, and I think it's just a great tool. So let me just bring it up here, and we'll do a little demo of this solar map. So here it is. You can access it on the City of Saskatoon website. It's free, and you can see all of the roof surfaces in the city. It's generated using satellite imagery and some AI algorithms. And let's just find a neighborhood here and zoom in, see what it looks like. So here we go. We can see the solar potential on these different roofs. It's nice and visual. You don't need to have a strong knowledge of what's going on to be able to look and say, oh, wow, brighter yellow is better in terms of solar exposure. The other great thing is it actually accounts for the shade cast by trees. So notice we have this nice south face on this roof. It's not showing up as nice and yellow, and that's because there's a big tree in the way. So why don't we pick a house with some decent solar exposure? And if we click on that house, we get to explore its solar potential. So it gives us some details on how many hours of usable sunlight per year we get on that roof. It shows us how much available roof space we have for solar panels. And we can choose, so let's say we're with SaskPower. Let's select SaskPower as our provider. We can put in our average monthly electrical bill. Let's just say it's $150 a month. And then it's going to tell us, here's what we would suggest for an installation, a solar installation size on your roof. So it's suggesting a maximum size of 18 solar panels, which would be a 7.7 kilowatt array. And it gives us some really nice, just preliminary costing and payback. So this is a great conversation starter if you've got a client who's interested in solar and is looking for a house with solar potential. Look at this, right? We've got our upfront costs, we have number of years till payback, and then total savings over 25 years. So this is a great tool for just that, kind of bringing forward those initial conversations when it comes to installing solar power. All right, that's all I wanted to cover in this module. We'll see you in Module 7.